Hello, my name is Dave Zapponi. I'm the CEO of ECHO, otherwise known as the Educational Council of Homeowners. I want to thank you for participating in our community conversation, Importance of Long-Term Preventive Maintenance. ECHO is a 51-year-old statewide nonprofit association established to support HOA board members and engaged homeowners. Our mission is to foster a better quality of life in community associations through education, advocacy, and connections. For today's event, we have a few housekeeping items. These are now presented on the screen. This slide deck was sent to all the registered attendees prior to today's webinar. Please take a moment to familiarize yourself with the housekeeping items on the screen. Today, we have a large audience of HOA board members. We will do our best to answer all of your questions, but may run out of time. At the prerogative of the presenters, they may or he may answer questions during the presentation or only during the Q&A session at the end of the webinar. We will answer questions as many of the questions as possible. In addition to the live Q&A session, I will be answering some of the questions via text in the Q&A feature during the presentation. To prioritize your questions, please use the upvote button in the Q&A feature. It's the thumbs up, and this button is at the bottom left of the left-hand corner of your screen, and those questions with the most upvotes will be answered first. It's easy and simple to use the thumbs up in the bottom left corner and vote for your favorite questions. Those questions with the most thumbs up will likely be chosen first. Also, please keep your questions general in nature and short. We may pass over some of the questions that are too complicated or too narrowly focused on your specific situation. If you have specific questions, we encourage you to talk with an attorney familiar with your community or another appropriate expert who can help you out directly. Please use the chat feature to report technical issues and to communicate directly with other participants in the webinar. We do not monitor the chat for conversations, the chat conversations for questions. So please, the chat feature is for technical conversations. If you're having a problem with sound or some other connection issue, talk to Connor about that and through the chat. Or if you'd like to speak directly to individuals, you can use the chat to do that. Now, let me direct your attention to your monitor where you will find our disclaimer. None of what is said during this seminar shall be construed as specific legal or expert advice from the speaker, sponsors, or ECHO. If you wish specific advice, we encourage you to contact your attorney or another suitable expert. The information we provide during this webinar is educational in nature and should not be relied upon for specific decision-making purposes. Thank you. This webinar, as well as all of our events, are made possible by the generous support of ECHO HOA professional service providers. Join me in thanking today's sponsors. Our registration sponsor is Levy, Erlinger and Company CPAs, our LLP CPAs. And then Collins Management in the Bay Area. For today's event, we will be giving away a $50 Amazon gift card at the end of the program, courtesy of CM Squared. To win, you must be present at the end of the webinar. Please support all ECHO professional members and especially our sponsors. They make our educational programming possible at little or no cost to you. And now for a bit about today's presenter. Kareem Malana is the CEO and founding principal of Alana Buick and Beers, Inc., ABB, an architectural and engineering firm that specializes in forensic analysis of construction, sustainable design of building enclosure systems, roofing and waterproofing construction, and construction management. Kareem has over 44 years of experience in the construction field and has acted as a consultant and expert witness in more than 1,000 forensic construction defect projects. For the past 37 years as the principal in charge of ABB, Kareem has overseen more than 18,800 architectural and engineering projects. with expertise spanning multiple engineering disciplines in civil, mechanical, and architectural. Clients include multifamily residential, federal, and local government, commercial, industrials, schools, colleges, and universities, insurance companies, and healthcare facilities, and HOAs. Kareem earned a BS in civil engineering from Santa Clara University and is a licensed professional engineer in California, Colorado, Florida, Hawaii, Illinois, Nevada, North Carolina, Oklahoma, Oregon, and Washington. He is also registered. He's also a registered roof consultant and a registered waterproofing consultant through IIBEC Inc. And at this point, I'd like to pass that on over to Kareem. Go ahead and start off. We appreciate you here today, that you're here today.
Well, David, thank you so much for your kind introduction, and and thank you for having us here to present this as your guest, as the guest for Echo. I am very proud to be here in front of you, the audience, and the Homeowners Association to present this. A couple of housekeeping items. The seminar that I'm going to be presenting is a copyrighted material. You will be receiving a copy of the seminar at the end. It's for your personal use, and by all means, use it for yourself, and you can share it with your board members, and if you're making decisions for your community and you need to use something. But please do not put it on the website. Do not send it outside of your area. And respect the copyright of the presentation. If anybody needs continuing education credits, including AIA, this seminar is eligible for that, and we can arrange those if you want. As Dave very kindly pointed out, I am the CEO and founder of Alana Buick and Burrs, and I got my start working for a roofing company in college. So I needed the money. I had a job for $5 an hour working for a roofing company. And so I worked for 3.5 years while I was in college and learned a lot about the trade, a lot about construction while I was getting a civil engineering degree at Santa Clara University. And after I graduated, I worked for Turner Construction Company, built buildings from ground up. And today would be over $1 billion of construction is what I was involved in. And then came back into the building enclosure trades and started this company when I was barely 27 years old. So I've been doing it for a very long time, for about 39 years now. Today, I'm going to focus on longevities of building assemblies. And one of the ways I was able to sort of create this list and presentation is studying. I've been studying longevities of building assemblies all my life. And the reason I got into this consulting business is when I was at this roofing company, I would watch some of the roofs that we were removing and tearing off and putting a new roof on. And these were commercial low slope roofs on apartments and condos. Some of them were 40, almost 50 years old. Same materials, asphalt, gravel, that's back in the day, that's what they used. And the average lifespan of the roof was, the average lifespan of the roof at the time was only 16 years. So I was very curious as a young engineer why majority of the roofs only last 15 or 16 years, and some of them will last as much as 50. And that was the quest that led me to starting this firm. And so I've been into longevity and durability of building assemblies all my life. And I'm here to share with you today, what you can do and expect from buildings and what you should do to get a longer life out of many of the things you're going to work on. So what is the definition of reliable and dependable and durable construction, right? A reliable building, assembly, car, whatever it might be, is something you can depend on to work without problem, right? For the life of the building. You expect a car to be running well into over 100,000 miles without really breaking down all the time. A roof is no different, a building facade is no different, a window or an HVAC system is no different, or plumbing system is no different. There are certain things that are built for a very long lifespan. And reliably built, they'll last a long time without breaking down, without having a problem. So we're going to talk a little bit about that. The life expectancies and what gives buildings and building assemblies their long life has actually only 15–20% of it has to do with the selection of materials and materials themselves. 80% or more have to do with construction quality, how well people built things, the labor force that built it, right? And if they made mistakes inherently, those mistakes reduce the lifespan of that assembly. So it's mistakes in construction that reduce the lifespan of buildings. So we're going to talk about that. And we're going to talk about lifespans of many things like waterproofing systems, exposed waterproofing on a balcony, versus a protected system where you've got a concrete topping slab on a balcony with a waterproofing that's hidden and concealed. A topping slab with concrete, that kind of waterproofing, that should last you 40–50 years. Should last you the life of the building. Waterproofing that's surface applied, that you're walking on, that you touch and feel. But those systems may need repairs or maintenance in as little as 5 years. And it could last as much as 20, depending on the materials you choose. Exterior skins, most of them are designed like stucco. It's designed to last the life of the building. If you're using stone and natural masonry and mass masonry, those will last you 500 years. And so sealants, things like caulking and sealants. People ask me, caulking is only a 1 or 2 year thing. I got to go maintain it. And I tell people, caulking and sealants are very easily can last you 25 to, I've seen caulking on high-rise buildings that are over 35 years old that are still functioning perfectly. And under those harsh conditions, under wind-driven rain, under sunlight. And so properly done, you can achieve a long-lasting assemblies. I want to briefly touch on what is typically not included in reserve studies, and it kind of touches on the longevity thing and touches on construction defects because you have defective construction, and that reduces the lifespan of something. Well, that's not included in reserve studies, right? If you're replacing a roof, and let's say the roof lasted you 20+ years, and now it's time to replace, the code upgrade to put extra insulation or sloping or added drains may not be included in the reserve study. The roof has rot and damage. It might not be included. Replacing things that are never in a reserve study. Like nobody expects to replace stucco. Nobody expects to replace windows in a building. Nobody expects to replace cast iron plumbing pipes. You expect those things to last the life of the building. And they should, but a lot of them don't. And then if they don't, and you had to replace them early, those are not included in the reserve studies often. There are other things that, that environmental changes, laws, fires, and all these things that create additional changes that are often not included in the reserve study. Things like retrofitted fire sprinklers that's required by insurance companies these days, ember-resistant mulch or landscaping that's done in such a manner where the larger trees are cut back a minimum of 5 or 10 feet. The canopy has to be at least 10 feet away from buildings. Those kinds of requirements and structural inspections and retrofits that are required by insurance companies become the norm these days, and that often an added cost. Things like electric chargers for cars are often not included. So coming back to the main theme of the presentation, which is longevity, right? Which is the number one factor that robs you of longevity in buildings is workmanship. The quality of workmanship is the number one reason. The number two factor is material design. And number three factor is design. But part of design plays into the workmanship. If the design is not there, it's not clear, it's not even there, and a roofer just gets up there and puts a new roof on, he's going to do it the way he wants to do it. That means he's a designer. He's a designer, he's the builder. He can make mistakes in the design itself. And so often, we get somebody to give us a bid, a contractor to give us a bid on siding. Oh, okay, he's getting a new siding, but there's nobody designing the siding or flashings. And so you're getting all of that is kind of lumped into workmanship. And that's what is the number one factor in reducing the lifespan of buildings. I'm going to also touch on maintenance versus repairs. There are inferior materials, there are inferior construction that require repairs to make these assemblies watertight, or to make the plumbing system not leak, or to make an HVAC system keep working, where your air conditioning system keeps losing Freon. And you have to keep calling a guy every 2 or 3 years to fill up the Freon. Well, the reason it's there, that problem, is because original construction, there is a slow leak in the Freon system. And therefore, it requires to be refilled every few years. And that's not maintenance. That's poor quality construction that got you there, right? So people say, my roof started leaking when it was 5 or 6 years old. It was under warranty. I called the guy, he fixed it. Then it leaked again at 7 years. And, I called somebody, he fixed it. And then it leaked again in 10 years. And the guy said, it's out of warranty now. And now I have to pay to fix it. Well, a good roof should never leak, and not leak for at least 20 or 25 years. I've seen roofs that don't leak for 40 years. So properly built, the roofs require very little maintenance. Often the maintenance that's needed is clean the gutters, clean the leaves, make sure there is no trees overhanging on the roof and damaging it. There's a hurricane or a storm, and there's storm damage that Mother Nature caused. You gotta fix it. Or human beings causing damage, you gotta fix it. But if none of those things are present, the roofs should last you 30, 40 years, right? So properly designed assemblies don't require maintenance. And maintenance is not what keeps them watertight. Maintenance doesn't really mean that you don't do this maintenance, it's gonna leak. Often people say, oh, it's leaking because it's not maintained. Your siding is leaking because it's not maintained. Your window is leaking because it's not maintained. And those things are not, most of the time, they're not true. Your buildings are not built that they should constantly be receiving sealant repairs so that they don't leak. So those are having to do more with maintenance, not maintenance. I'm going to pause just a little bit. Actually, I'm going to go through this before I pause and ask some questions. But some of the things that are the owner's responsibility are, I don't know why my video is not showing up, Connor. Just want you to be aware of that. There's something wrong with the video feed. It's not on my end. Connor? Okay, I'll keep going. Hopefully you guys are not necessarily looking at me. What are the items that are owner's responsibility, right? So there's a severe storm, earthquake, hail, hurricane, lightning strike, damage from a tree falling, roots that grew underneath something, damage from cars or foot traffic, damage from vandalism or abuse, damage from oils and chemicals. Those can hurt the roof, those or building components and assemblies, and you may have to fix them because it's your problem. However, outside of these things, a lot of things are just normal stuff. So can durable assemblies and buildings be built, and the cost-wise, does it make sense to build them? Generally speaking, it costs about 10 to 15% more money to build something that is going to be a lot more durable. You can double or triple the lifespan of siding, of windows, of roofing, that it can impact the lifespan of the building. So when does it make sense for an owner to spend more money? I think that often boards and associations make decisions based on limited funds. They don't want to do an assessment. They want to make a decision of getting something cheaper, cutting out engineering, But long term, that may cost you, right? Instead of a roof lasting 30 years, or instead of a siding lasting you the life of the building, instead of windows lasting you 50 years, now you're cutting down the lifespans of these assemblies. And you may be cutting it down by 50%, maybe cutting it down by 70%, the lifespan of these assemblies. And I think that eventually that catches up to you, then eventually the assessments go up, and eventually your dues go up, because now your replacement cycle is much, much faster than it could have been. So lower maintenance and lower operating costs have their benefits, and it's a long-term strategy. If you do it right, you will reduce the frequency of maintenance, and you will build assemblies that will last longer. And that's where we need to go with my, that's my philosophy. I'm going to show you a bunch of examples at this point in time of things that, how they're failing prematurely, how some of the things are lasting a long time. I'm going to show you real life examples of many, many investigations that we have done in curtain wall systems and exterior walls and roofing systems. And I'll give you some real examples of how to change the dynamic of things. But before I go there, I'm going to read some of the questions that have been asked. So one of the questions is, for roofs in particular, what is the action life percentage-wise needing repair for consideration of full community replacement? And in terms of, again, percentage of roofs that need repair, in reality, I would say 70–80% of roof need repairs. And they need repairs because they were originally not built correctly. I would say 70–80, maybe 90% of the time, the repairs you're making to the roof that are young, that are 10, 15, 20 years old, is because things weren't built correctly in the first place. That's what's requiring the repairs. I've designed roofs and assemblies that I've designed roofs, for instance, that are 37 years old today, and they're still there. Nobody has done anything. No repairs were ever made on it, right? Because it was designed to last that long. I hope that answers that question. The next question is, what type of firms evaluate those components, which are often not included in early reserve studies, but should be added to those HOAs which are 50 years old or more? So I'll give you examples. There are electrical panels that are today mandated by insurance companies that have to be replaced because of fire issues. Cast iron piping, they're hardly ever included in replacement cycles. 50-year-old buildings, I can almost guarantee that you might have to consider replacing your cast iron pipe. That's going to be a very expensive repair while the building's occupied. Your plumbing systems and some portions and parts of your plumbing systems may need to be replaced, or in entirety might have to be replaced, that people never thought of. Windows don't, after 50 years and in that time frame, the windows are old, they're drafty, they're not insulated, and they're not quiet. And they probably will be leaking, and the frames will be falling apart. And I'll show you examples of those. Those kinds of things will need to be done in 50 years that may not be covered by a reserve study. So I hope that I answered that question. The next question is, do you recommend getting an engineer to evaluate roofing building concerns before getting bids? Absolutely. You should not just hire an engineer, you should hire an engineer that specializes in roofing. You're doing windows, hire an engineer that specializes in windows. There are experts out there like myself, like my firm. We have 250 employees. As part of what we do, we go out and we have experts in all of these subject areas, and we go look at it very carefully. And often I get called by a client that says, I need to replace the roof. And I ask him, why is it leaking? And I go, it's not leaking, but it's 25 years old, and I budgeted to replace this roof in 25 years. So I go look at it and I come back, I said, you're one of the lucky few. You have a roof that probably has another 10 or 15 years left in it. There's no reason to replace it. I can give you a list of 5 or 6 things you can do to fix it. It cost you about 2% of the construction cost to fix it, and it lasts you 5 to 10 more years. So an engineer will give you an objective advice like that, because they're not there to replace this roof. They're not there to go fix, something. They're just here working for you on an hourly basis to give you advice and give you share their knowledge. So that's my advice. Secondly, an engineer will also design provide a design for flashings, for siding, for windows, and specify what you want, what the product should be, and so on and so forth. So those are very important things. The next question is polyfresco, torch down, or TPO. HVAC platforms are on the roof, so access is common. I don't quite fully understand the question. Torch down or TPO, I guess, is one question. It depends. It's very specific. It's very specific, and I would say that TPO roofs are probably my least favorite from a pecking order. If I'm doing a single ply, I prefer PVC over TPO. They have a longer lifespan. A PVC I'll show you in the PowerPoint when we get to the roofing, a difference between TPO and PVC. Between a TPO, PVC, or a torch down probably will outlast a single ply because it is tougher and less impact damage and less damage, more damage proof than a single ply is. I'm going to move on because I know there are a lot of wonderful questions. We're trying to get those questions answered, but I think some of these questions will probably get answered in part of the presentation. And so I don't want to get behind. And so I will move on. All right. I talked about sealants, caulking, as a lot of people call it. Us engineers, we call it sealants. We don't call it caulking because caulking implies something on the interior. You know, you can do caulking for painting, and painting people do caulking. Sealants are done by waterproofing subcontractors that know performance. They are looking for performance of that sealant. On the left is a sealant that's about 7 years old and is prematurely failing, and it's done. It needs to be replaced, and you can see the cracking in the middle. You can see that it's turning gummy, and it's not working. On the right, this is silicone sealant, okay? And a properly installed silicone sealant, has 20 to 25-year labor and material warranty from the manufacturer. GE and Dow will give you more than a 20-year warranty on a silicone. I've personally seen silicone sealants on high-rise buildings last over 35 years. Silicones are just an absolutely amazing, miraculous product that can last a super long time. What is the cost difference between these two? A polyurethane sealant may cost you $7 or $8 a lineal foot. A silicone sealant may cost you $10 or $11 a lineal foot. The cost difference is maybe 10%, 15% between this and this. So you want sealants that last you 5 to 7 years, or sealants that last you 40 years. The cost difference is 15%. You know, take your pick. But on the right-hand side, you can also see that the sealant is properly tooled and applied and pressed into the edges. It has to make proper contact with the edges. All of those things are really important for the sealant to perform. So it's not just the material. I wish it were that simple, but the quality of the workmanship also has to be there. Another example of longevity. This is an anodized aluminum. It could be handrails. It could be window frames. All right. A lot of people have to make decisions about replacing their handrails. Handrails, aluminum anodized handrails, if they're anodized with class 1 anodization. Majority of homeowners, they get bids for anodized, they're class 2 or they don't even have a rating, okay? Class 1 anodized, properly anodized can last you 25 plus years. Class 2 anodized or not rated anodization will probably last you 4 or 5 years. So big difference between just the anodization and the quality control of the anodization. But better than anodization is Kynar. A Kynar coated window frame will last you 35, 40 years. I've seen, you know, projects that are over 40 years old that have Kynar in them. Kynar has been around for 64 years. And it's a very, very amazing type of coating, although it's currently having some issues, that type of coating, and I'll get into those issues in a bit. I'm going to talk about life expectancies of horizontal waterproofing assemblies. Okay, there are two types of waterproofing assemblies that are horizontal in nature. One is what I call a trafficable waterproofing assembly. A trafficable, by that I mean foot traffic, people traffic, balconies where you're sitting down and having coffee and there's coffee table and chairs and people are walking on it. Or it's parking structures where it's waterproofed and you're driving cars on it. There's drive aisles, you're parking on it, you have ramps on it. And so those are all called trafficable waterproofing systems. Trafficable waterproofing systems can last you, polyurethanes will last you 10 to 20 years, but they have to be recoated every 4 or 5 years. But that's going to be about the limit of its lifespan. So it does require, you can call it maintenance, or you can call it a recoat. I call it a recoat, and it's going to require some recoat every 4 to 5 years. If you wanted a longer term product, PMMA, polymethyl methacrylate. PMMA can last you, you'll get a 20-year warranty, but in reality, a PMMA on a balcony will probably outlast you 40 years, right? And it may require recoat and a traffic, like a vehicular traffic area may require recoat 5 to 10 years or 10 to 20 years, depending on how you put it on. Nobody does acrylic coatings anymore. They don't last very long. And so the lifespan is maybe 5 to 10 years and the recoat cycle maybe as little as 2 years. The last item in this category is lath-enforced polymer modified cement. These are cementitious materials, kind of look like stucco on the floor. They're trowel applied, they've got a texture, and there's a paint on it, paint color on it. They have become very popular, especially in California. And they're exposed waterproofing that you walk on. It's about 1/4 of an inch thick. It's usually reinforced with metal lath, just like stucco is. It's just a thicker, thinner version of stucco on a horizontal layer with special kind of cement. And these can easily last 10, 20 years with a recoat required every 3 to 5 years. And the recoat cycle is pretty simple. It's like a roller applied coating that goes on top. But these are not a bad option for a less expensive option in a monolithic kind of setting. Concealed waterproofing. What does concealed waterproofing mean and what are their lifespans? Concealed waterproofing is something that has an overburden. So you applied your waterproofing and then you put a concrete topping slab on it. So you're walking on topping slab, you're walking on concrete, you're not walking on the waterproofing. The waterproofing doesn't see the light of the day, literally. No sunlight gets to it. No, water gets to it, but no sunlight gets to it. No foot traffic gets to it. So it's concealed. It's also called a protected roof assembly. So protected type of roof assemblies that are underneath pavers, inside of planters, and will last you 50 plus years, right? They're designed to last you a long, long time because there's no UV, there's no foot traffic. All they have to do is keep water out. But they often don't. Majority of them will fail. More than 50, 60% of them fail in less than 10 years. And it's because they're built wrong, but they're supposed to last for life. This is an example of a trafficable waterproofing where you've got a garage ramp, and you can see the waterproofing membrane that they're working on. And this type of a trafficable waterproofing, if it's PMMA, can last you 20, 30 years. If it is polyurethane, it's probably a 10-year type system, 10 to 20 years at the most, and you need to recoat every 5 years. So get both cost estimates, but PMMA can be close to double in price. So it is, first cost is so expensive that most people don't opt for it. But if you're in a situation where your parking is critical and you can't shut down your garage all the time, and the shut down the garage costs a lot of money, we've had homeowners that have elected to go with PMMA because they're not going to have to shut down the garage for another 25 years. And that makes sense for them. But if you're okay with shutting down the garage or limited your parking every 5, 6 years, you're okay with the polyurethane. It's going to be cheaper. Here's an example of an older polyurethane coated type of a system that failed, right? And the coating failed, and as a result, you can see in here, the concrete had also failed. The water got inside of the concrete, got to the rebar, rusted the rebar, we had to actually take a layer of concrete off and fix the reinforcing steel that had all rusted out inside of this deck. And this was about 10 years old when it had to be redone. Underneath, when these things leak, you get damage. You get damage in the slab, the concrete starts to spall, you've got rust that starts to happen. And this is more common in older buildings, is concrete, can take a lot of beating before it gets to this condition. But once it gets there, it's going to be more delicate and it's going to suffer more damage and more spalls as time goes on. Here's another example of damage from from a parking structure that had post-tension cables. And in this case, the post-tension cables themselves have rusted. In order to replace these cables, it costs a lot of money. You got to pull them out from one end and replace them. You have to shut down parts of the building. And it's a very expensive endeavor to replace post-tension cables that are often in these garages. This is an example of PMMA, or polymethyl methacrylate coating. It's a very monolithic, beautiful looking coating. And you can put stripes on it. You can write things on it. You can jazz it up with many different colors. And this type of a coating, again, is designed for a 20+ lifespan. If you had a coating like this with maintenance 20+ years, probably last you 50+ years in a setting like this, where you have a parking structure where you're driving cars on it. It may be, you'd have to replacement cycle will be a little more often. This is an example of polyurethane coating going down on a balcony deck that is being redone. And again, a 5 to 10 year recycle, but you could see this blister forming right here. And this blister is forming because they didn't properly prep the substrate. The substrate had moisture, didn't properly remove the old coating. The old coating was not properly bonded, so it sort of blistered on you and came up. And so proper construction is really important for the lifespan of anything, right? Without proper construction, things will fail very quickly. Here's an example of a walking deck, of wood framed walking structure to facilitate people into getting into the condominiums. And when this waterproofing failed, this had a topping slab that was removed. It was an extraordinarily expensive endeavor, right? So this replacement cost is in the $80 to $120 a square foot. The cost of the waterproofing is only about $10, $15 a square foot. But the overall cost of this deck is more than $100 a square foot, because waterproofing only amounts to about 10% of the cost here. The rest of it is the overburden, the concrete you have to remove, the concrete you have to pour back, all the framing damage, all the framing corrections, all the slope corrections. All the doors have to be opened up and removed. All of the siding layers have to be removed. Portions of the siding here was removed so you could tie into the waterproofing. And then imagine access to these units is limited. So every night they have to provide plywood. Every in the evening and afternoons, they got to provide plywood access so people can come and go in the morning and come back in the evenings. And so it's a nightmare type of repair. And it's very important that if you have to replace something like this, that you build an assembly that's actually built the lifetime of the building and wouldn't fail on you prematurely again. Premature failures are often not covered in the reserve study, right? They're not covered. So if you had a walking deck, chances are that unless somebody's investigated it and you maybe done an SB 326 investigation, you figured out that your balcony needs work. Now you've gone back and budgeted for more money for this. But often they're not just plugged into the reserve studies. They may have to be added. Improper design. If things are designed wrong, installed wrong, you're kind of stuck with its reduced life or premature failure. A lot of people use unproven waterproofing materials, improper thickness of materials, improper application of materials, drainage is not properly designed, surface is not properly prepped or primed. Any of these things can cause a failure. So failures can result from many, many simple things. And I'll show you some examples of what kinds of things cause failure, like in a balcony deck. Here, the person that was doing the flashing, instead of having a soldered one-piece corner saddle here, they just took a piece of tin and bent it and cut it and just, wrapped it around the corner and called it a day. Well, this has never been watertight. And they try to lap another piece into this to sort of make it watertight. And that's not how you build these things. They didn't solder anything. This is not soldered one piece, soldered watertight assembly. And it didn't last as a result of how it was built. Drainage, this is again a protected assembly with concrete topping slab. And the guy that poured the concrete, he didn't make sure that the weep holes were protected, and he blocked up the weeps in the scupper. And so the water would puddle back and cause all the flashings to rust out because the water was standing at that height. And this, again, they used galvanized sheet metal. Galvanized sheet metal is a very bad choice for a deck like this. It should have been stainless steel or copper. Galvanized sheet metal in a deck like this has a lifespan of between 3 and 5 years. Okay, that's it. And you're building an assembly that's built for life, and you're putting an ingredient, a component in there that has a 3 to 5 year lifespan. I mean, what are people thinking, right? You never want to do that. But this is a very common occurrence where we see this all the time. I mentioned improper material usage. This is a asphalt modified polyurethane. And asphalt modified polyurethanes are proven to not work. So 99.99% of the time, they fail. And so if you have asphalt modified polyurethane, this is the least expensive waterproofing membrane that is sold on the market. 40% of today's horizontal waterproofing is done with this product. 99.99% of the time they fail. And they fail within a few years. And what happens to them is they get water-filled blisters, as you can see here. And water-filled blisters, or they just swell and they just basically fail. And so it's just a bad choice of materials that should be avoided at all costs. So what are the key elements for waterproofing assembly? Selection of the right product, right? Selection of the proper flashings like stainless steel and copper, properly built flashings, proper drainage, proper protection from traffic and damage from trees, roots, freeze thaw, et cetera, et cetera. So all of these things, if you do them correctly, they will last the life of the building. I'm going to talk a little bit about roofing, and I'm going to talk about the fact that the roofs are, once again, capable of lasting more than 40 years, but most don't. And somebody had originally asked about a single ply versus TPO versus torch applied. So I'm going to try and answer some of those questions here. Okay. So first of all, any of these systems can fail prematurely if it's not done right. Right? They can all fail prematurely. But some of the materials will outlast other materials if they're done properly. So I'm going to talk about that and what are the common causations of materials failing. This is a roof that is at least 34 years old at the time I took this picture. And I want to say this was on the building for the county of Sonoma. It's a commercial building. And they had never, ever experienced a leak. They were ready to re-roof this building. I told them they don't need to. This roof's going to last another 10 years. And they left it in place. There was nothing wrong with it. There's not a shred of anything wrong with it. This is a similar roof that is gravel surfaced that's less than 25 years old. I want to say closer to 20 years old, that was failing on the right-hand side. You can see where the sheet metal comes into the roofing. It was splitting right here. Okay, and this was splitting because the sheet metal was not properly nailed. If you don't properly nail the sheet metal, it's going to cause the roof to split. Attachment is one of the most important things in the roofing system. Improper attachment will cause failure. Talked about TPO. Somebody asked a question. Right-hand side is a TPO roof that is 5 years old. And it's basically turned to paper mache. And if I pick up this sample, I put it up under daylight, the sunlight comes right through it. This is the only thing that's left here is the mesh. The membrane is gone. Okay. On the left-hand side is an 18 18-plus-year-old, I want to say closer to 20-year-old PVC roof, and still doing okay. This roof had a 20-year warranty, and by and large, it lasted 20 years. And ultimately, this building was torn down and was, I believe, at that point removed in about 23 years of age. But up until then, they never replaced this roof. A lot of premature TPO failures. TPO industry had a problem. This is another 7-year-old TPO roof that's failing. I'm going to show you some more pictures of a TPO roof that is failing. You can see the mesh, you can see the membrane is just completely delaminated, and it's underneath the black walking surface. So where the failure is happening has no ultraviolets. The sun doesn't shine there. Why did it fail? Right? It didn't fail from the sun. It didn't fail from ultraviolets. It failed from heat. It's a heat-induced failure. So assemblies that are exposed to the elements, or even plumbing systems like PAX piping and Victaulic couplings in the plumbing assemblies, they're all designed to handle oxidation. Oxidation can happen from the sun, can happen from the heat, can happen from chlorine, can happen from chloramines in the water supply, right? So all these things are antioxidants that are constantly acting on your material. They're trying to gnaw away at it, and they're trying to take its lifespan down, okay? So heat is one of those elements that is actually causing failure to the TPO prematurely, because the antioxidant packet they put in the TPO was the wrong type. They made a mistake. They put an antioxidant packet that wasn't lasting, because the roofs get so hot every year for so many hours a year, like 400 or 500 hours a year, the roof could be at 160, 170 degrees. So when you accumulate 400 hours, 500 hours of 160-degree temperature, 170-degree temperature for 5 or 6 years, the antioxidants are gone, right? That they're basically, the job that they were there to serve is over. And at that point, they just turn to mush. Now, since the time, this was discovered by me, and I presented this information to the world about 10 years ago, 12 years ago, and there was a big, there was a lot of issues with me presenting this to the general public, to the construction industry, to the roofing contractors, to the manufacturers. And there were a bunch of manufacturers that wanted to sue me for releasing this information into the public. But I was sort of the whistleblower. And I released this information to the public. I did my research, and I actually looked at 26 roofs that were failing prematurely and did a very thorough research. As a result of that, the TPO manufacturers have now revised their antioxidant package. They're now putting in better quality antioxidants in their materials. They're offering warranties for warmer climates. They're changing their materials that would sell into a warmer climate like San Jose or Sacramento, Las Vegas, and other parts of the country, as opposed to like San Francisco or Seattle, where it's cooler. So the jury is a little bit still out as to how long the newer TPOs are going to last with the newer antioxidants. But I'm an old-fashioned guy. I want to look for products that I have a proven track record with, and so we are using some TPO in our application, but we are limiting it to some non-critical type of roofs. Somebody asked about modified bitumen roof. Okay, this is a typical modified bitumen roof. Again, not installed correctly, not properly sloping, has ponded water. You can see the damage that somebody has repaired on this roof because of ponding water and other issues. Improperly done, you see the wood is just sitting, the sleepers are sitting right on top of the membrane. That's not the right way to roof this in. This roof, improperly done, again, 15-year, 20-year lifespan, that's about it. Modified bits done correctly, the right layers and redundancy, 30, 40 years is probably how long they can last. Here's an example of a modified bitumen torch applied type of roof that lasted This is only 5 years old. It was failing. You can see this roof is ridging. You got these upturned ridges in the roof. That's happening. I investigated it. I removed a plug from the roof to see what was wrong with it. And essentially, the insulation in the roofing assembly was fastened with this kind of fastener. This is the wrong kind of fastener. This type of fastener is not supposed to be used for fastening the insulation. It's supposed to be used to fasten a base sheet. And so because of that wrong use of the fasteners were pulling out, and the insulation board was curling, and these lines that you see is the insulation board curling. And so here's a roof that could last 30, 40 years, and it's failing in 5. This is what was happening. The fasteners were pulling out because there's a wrong kind of fastener. Insulation board was curling up, and it was causing splitting of the membrane where these ridges were forming. Okay, so that sort of kind of ends the roofing portion of the longevity, and I hope that made sense to you all. And not sure what questions came up in the roofing section, but at this point, I'm going to keep going. I'm going to try and wait until the end and see how much time we have for questions. I'm going to talk about podium waterproofing, right? We talked about horizontal waterproofing. This is a horizontal waterproofing assembly that's protected. It's a protected roof assembly. Planters, hard surfaces, tiles like this, pool decks. This is over a parking structure. And so this is a protected roof assembly. And this is supposed to last the life of the building. So if you look up in your garage and you see leaks and water intrusion, that's not supposed to be there, okay? Your leaks are going to be limited. Even in 5 to 10 years, all you're going to see is little dots of water, little rust spots. So you have to look at this and kind of know that something's up, and something could potentially fail. And something has failed, actually, not potentially, but something has failed. And if this roof assembly or this protected roof assembly has failed, you're done. You have to replace it. And the cost of replacement is like $150, $200 a square foot. Very, very expensive to replace. You can see rust coming through the concrete from the leaks above. All of these pictures I'm showing, these are all buildings with podiums that are less than 10 years old, okay? Most of them are in the average age of 5 to 6 years that have failed. You can see the planter waterproofing has failed and it's leaking. This is the cold applied polyurethane system that's failing. And I talked about this asphalt modified polyurethane system, and you can see there's water underneath it, moisture underneath it, and it's got blisters. And if you cut these blisters, water pops out of them. Some of the blisters get very large like this, and they're all filled with water. And what causes these water-filled blisters is osmosis. And osmosis is formed because concrete has salts in it. And when fresh water gets through this membrane, it hits the concrete, dissolves with the concrete, and then you have a salt water layer at the bottom and fresh water on the top. And the fresh water is drawn into the salt water because of the ionic difference between the water. And it causes these blisters to form with salt water and fresh water on the outside. So that's the formation of the blisters we saw in the polyurethane. So waterproof membranes should not be permeable. They should be impermeable. Manufacturers will tell you, I have a permeable membrane. It's going to dry out the concrete that's wet. Don't believe them. You don't want a permeable membrane. You want an impermeable membrane when it comes to waterproofing. And this is a very common failure that happens in assemblies. Balcony decks. Again, these are trafficable, require maintenance. Pool decks, you can see that this spa is failing. Water is coming through this. You can see that the stone coping around the pool is lifting up and failing. It's a very common failure we see. And again, it's improper construction that's leading to this premature failure. And it just was never properly bonded down. And you can see that there's no cement and no concrete or mortar stuck to the bottom of the concrete. It just came off really easy. So a lot of these are related to waterproof failures. Some garage leaks and garage failures that we see here, again, they're not meant to be there. Garages are designed to be waterproof for life. You don't get back into a garage 10 years later or 5 years later, try to fix it. cost of repair of these walls that had to be fixed, if they had to be fixed for waterproofing, or the flooring and the slab, is roughly $80 a square foot. You have to inject behind the wall, you have to inject waterproofing behind the wall to fix it. And the injections are every 18 inches on center, staggered throughout the whole surface. It's a very, very expensive and painstaking repair. And so if this is happening, you should make a note of it. And it's most likely not going to be covered in your reserve study unless somebody has looked at it and made an estimate for it. So the lessons learned is good quality construction really impacts the bottom line, right? It really impacts the short-term, long-term performance. And if somebody asked is, do you recommend hiring an engineer? Yeah, absolutely. And this is why you want to hire an engineer. You want somebody that knows what they're doing to specify it, design it, watch over it, inspect it, test it to make sure that it is done correctly. I'm going to move to another topic, windows and glazing. I've got about 10, 15 minutes left, and I'm going to try and hit this pretty quickly, and then I'm going to turn and answer questions. So windows come in so many different styles and types. It could be high rise, could be low rise, but they have many things in common. They have glass, they have gaskets, they have coatings. They have aluminum coatings or vinyl framed windows, and so they have many things in common. And they all can have problems. And I'll go over the problems that we see, like in gaskets. Gaskets are commonly made with EPDM, and EPDM is a synthetic rubber. And it's extruded and applied, and the gaskets are what separate the frames from the window. Okay, we see so many gasket issues these days, far more than what we saw in 30-year-old buildings. We're seeing them more and more in the more newer buildings. Starting about 15, 20 years ago, the quality of the gasket materials went down. And from the last 20 years, we are seeing a lot more gasket failures. This gasket is not made out of EPDM. It's made out of another synthetic rubber called Sanoprene. So heat weldable material, you can see that it's graying. This is an EPDM gasket that's essentially shrunk. You can see the shrinkage right there in the corners. That's your gasket material. And because it shrunk, it was allowing a lot of water to intrude in the assembly. And that water eventually, comes into the gasket, goes up on the other side of the glass and leaks inside. And this is a typical leak that we would see in a gasket due to a gasket-induced shrinkage failure. So gaskets can not only cause water intrusion, they can also cause condensation. I'll show you some examples of that. This is a vinyl type of window. The vinyl windows are actually built a lot, not as well as an aluminum window is. And often they deploy cheaper materials that go in it. So it's inherently the vinyl windows, if they're not properly designed, will not last you beyond 20 years. For instance, these vinyl windows had a gasket that was made out of acrylic. It was an acrylic foam. They were using an acrylic foam as a glazing gasket. That acrylic foam only had a lifespan of like 5 or 6 years. After that, water would get in and would leak, come out the other end and leak. So these acrylic tapes break down with UV, they break down with water, they're water soluble. One of the problems with gasket failures is that they let air come in. When gaskets fail and air starts coming in, you get condensation, you get dirt, you get condensation, and the condensation then turns into mold. And here's another example of mold. Water standing and on condensation. This is San Francisco in a mid-rise building in a winter day when it's sunny outside. As many of you know, it gets cold in San Francisco, but here's a sunny day, it's sun outside, and inside these frames have standing water. And this standing water is from condensation, not from a water intrusion. It hadn't rained in weeks. And what caused it to happen is air was blowing through the gasket, coming inside, and that chilled air was making the inside frame cold. Underneath the glass is a thermal barrier. The outside aluminum and inside aluminum are not connected. They're separate. And they're separated by a thick thermal barrier. So they don't touch, they don't induce cold and warmth. And so this side inside got cold just because of air leakage, right? So if you see this, this is an inherent construction problem that's causing the premature failure. I'll give you another example of coatings. Aluminum is the most common material used for windows and curtain walls. And what we see is a lot of coating failures, premature coating failures in aluminum. You see aluminum coatings blister and bubble kind of like this. You're seeing them, then you can see the you can see the bubbling and the blistering of this coating. If you see this, you know that there's a problem. These are small little blisters, and these small blisters join together to form bigger blisters. And this is become a very common problem. About 20 to 25% of all new construction built in the last 15 years have this failure. So you have to be on the lookout for it, because the cost of repair could be covered in the first 10 years. It could be covered by statute of limitation. The developer may step forth, the insurance company may step forth and pay for it in the first 10 years. But if you miss that 10-year window, you as a homeowner has to pay for it through a special assessment, and the cost of this repair is very, very expensive. Again, another example of a frame that's blistering, okay, in a curtain wall setting. And after the blistering, they start to pit and get, this, it basically rots away the aluminum frame. This is the rotting away the aluminum frame in less than 10 years. So aluminum coatings and window coatings are designed to last. Actually, they'll get 25-year warranties. I've seen them that are 45, 50 years old. They're faded in color, but they're still okay, and the aluminum is still protected. The underbelly of the coating has chromium chromate, and that chromium chromate can last you like for 100 years. And so even if the coating fails, the underbelly is built so well that typically these things were supposed to last you the life of the building. But today they are not doing so. And they're not doing so because they changed the pre-treatment, they changed the underbelly of the material, and they cheapened it because of environmental reasons. The code, chromium chromate is a carcinogenic, so they changed it to something different, and that caused this premature failure. So you should be on the lookout for this. If you see stuff like this, or even a chalky paint on the aluminum coatings, then you know that there's a problem, and you should call an expert. Last part of the presentation, I'm talking about glazing glass, and IGU insulated glass is designed to last, again, the life of the building. They usually have a 20-year warranty, anywhere from 10 to 20 year. 10-year warranty is minimum mandated by law, but most manufacturers will provide a 20-year warranty on this. So if you see this type of a failure happening, you may have a more widespread problem, especially if you see a lot of this. If you call the glass manufacturer, they'll give you a free piece of glass, but you may have to pay to install it. The way insulated glass works is that the glass, this is glass on the outside, this is glass on the inside. This thing here is called a spacer, okay? The spacer is hollow, and it keeps the space apart between the outside and inside glass and creates the air cavity. The air cavity is what gives you insulating quality. On the face of the inside glass is a low-E coating that's applied. The low-E coating improves the thermal efficiency of that glass, okay? These here are desiccants. The desiccants, and there's holes on the top of the spacer. The desiccants are there to absorb any moisture that gets inside of the glass and sort of protect the air inside. If the air gets humid inside, the low-E coating is going to fail. Down here are two sealants, silicone and butyl. They're both number 1 and number 2. Butyl is the primary seal, silicone is the secondary seal, and they're both there to protect water from getting there. So if done correctly, no water should ever get in your assembly ever, right? And you don't even need the desiccants to dry anything out. But if the sealants start to fail, water and moisture starts getting in, it'll attack the low-E coating and condense on the inside, and the low-E coating will start to fail. And you can see where the low-E coating starts, which is right at this straight line edge. And you see the bloom of failures that's forming along the edges of the glass because moisture is coming in through this this failed sealant joint at the IGU interface. So your low E coating is on this side of the glass, and typically it's deleted and removed where the sealants are. And so that if that's not done correctly, that can result in premature failure. And here you can see the manufacturing, the low E coating is getting deleted in here. And it's an important step in longevity and making these things last longer. The second element is how the assembly is built, because it may be built to allow water to come inside and behind the silicone sealant. And if the water sits on top of the glass, on top of the IGU, it'll cause it to fail prematurely. And in fact, it takes away the warranty. Manufacturer's warranty would be gone if water is sitting on top of the glass. It won't warrant their system. So it's a serious problem. Why is it a serious problem? It costs over $10,000 to replace one piece of glass. 10 grand. Okay. And why does it cost 10 grand to replace one piece of glass on like a high-rise building? On a high-rise building, you need 3 people on the rooftop. Okay, 2 in the rig, 1 standing there with a wrench. You need 3 people on the inside. You need 6 guys to replace one piece of glass that can manhandle, remove the glass, manhandle it, take it down the elevator, bring in a new piece of glass and install it. And if it's a bad windy day, they shut down in the middle of the day, they have to come back the next day to finish the job. So it's a very expensive procedure, and it can cost, in a high-rise building, it can easily cost $80–90 million to replace all the glass. It's a very expensive thing. So be on the lookout for some of these things that are failing prematurely. How do you prevent this? Have professionals inspect, okay, and look for early signs of these failures. If you can catch them in less than 10 years, they'll probably be covered by warranty, probably be covered by insurance company, probably be covered by the developer who may come in to fix it. If it's after 10 years, forget about it. If you notice an issue and you do nothing about it for 3 years, you still lose your statute of limitation. If it's a concealed damage and you first discovered in year number 9, you're still covered. Okay, so this is an important thing for you guys to know, that if you're trying to fix something on a new construction, new build, you should know the statute of limitations and what they mean and how they can protect you. Okay, I think we've kind of come to the end of the seminar, and I would love to open it up for questions, or I can go to the questions. So Adrian, or if you want to ask me some of the questions that have risen to the top, the number one question is termites often alter the once well-built structure. Does tenting fumigation factor to the maintenance matrix? The termites are, again, in wood structures and older structures that have a lot to do with how close we are to the ground. Okay, if it's the ground termites that are coming in from the dirt, you really have to do some serious termite proofing. And if it is a structure-borne or airborne termites, they're easier to fix. They do very little localized damage. You often don't have to do tenting for those. I'm going back to the most upvoted questions. It says many condo projects were built in the 80s, and I think I already answered this question. What with concrete covered waterproofing, isn't it a problem that the nature of concrete is to crack? Okay, I think I understand this question. Concrete, there are 2 types of concrete. One that cracks, one that's going to crack. Concrete is always going to crack, okay? Waterproofing that goes on top of the concrete is designed to stretch over the crack. It's called elastomeric. Elastomeric because it's elastic. And you put the elastic membrane in thick enough where it'll stretch over the crack, okay? So it does handle the cracks, if that's your answer. I said, although you said the stucco has a very long life, what happens if moisture gets in? Stucco is very long. What happens if moisture gets between the stucco and the supporting wood? won't there be rot? So stucco-wise, when moisture gets trapped between the stucco and the wood, believe it or not, it dries to the inside. It doesn't dry to the outside. Sun hits it, that moisture is sucked into the inside, is dissipated by the air conditioning system. If lots of water is getting in, it will lead to rot. That's bad quality stucco. So that has to do with the quality of the stucco. You can do something to protect it, doing elastomeric membranes and that sort of thing, but that's just a bad quality stucco that's happening. The next question is, when hiring a construction manager on a major exterior project, what type of certification should a board expect to ensure that most all correct construction methods are used? Okay, so the kind of certification I would look for, someone with credentials that does building enclosure for a living. You go to their website, that's what they advertise, that's what they talk about, that's what they do, right? Number two, there should be an engineer or an architect, preferably. Number three, they should be registered, have registration in waterproofing, a registered waterproof consultant, a registered roofing consultant, a registered, with somebody like an independent agency like IDEC. And so those are the three things you want to look for qualifications.
Kareem, we have another question that's been upvoted. It's should original flat roofs be designed as they are causing leaks? We just keep fixing them.
You're fixing them because they just weren't built right. I've designed flat roofs that have been watertight for 37 years and not a single leak, right? I guarantee you I can design and manage the construction of a flat roof. But by flat, they're not perfectly flat. They're called low slope roofs. They should have a slope of at least 1/4 of an inch per foot. So it's not a lot of slope, but that's all you need. They have a slope of 1/4 inch per foot. You design it correctly, you install it correctly, I guarantee it's going to last you more than 30 years. So if it's not doing it, it's because you just keep repeating the same mistake, paying for a cheap roof from someone that doesn't know how to build it. Hire an engineer to get involved and help you get there in the longevity. What's the next most upvoted question?
Based on the Business and Professions Code, BPC, Division 3, Chapter 3 is a licensed architect or licensed civil engineer required to sign and stamp plans, drawings, specifications, reports, documents, and instruments of service for multiple dwellings containing more than 4 dwelling units and more than 2 stories in height. For the same dwelling type, is a licensed architect or licensed civil engineer also required for investigation, evaluation, consultation, advice, planning, schematic, and preliminary studies?
So preliminary studies, probably not. You could get anybody to do it. But if you are doing construction and construction drawings are being done and they're being submitted to the city for permits, the city will require that the construction documents are stamped by a licensed engineer and architect. So generally speaking, a third party doing the work will require a license. A contractor can apply for a permit without design. So that's usually what happens. You have a non-licensed professional, does some design, if a contractor just goes to the city and they issue him a permit. That's not uncommon, but that's not the right thing to do. Any other questions?
What do you think of a roof max treatment?
A roof max treatment for shingle?
I assume so.
Don't quite know what exactly you're talking about. I don't know the terminology that, this is sort of a proprietary thing that somebody is selling. And
Okay.
so I need more information. There are lots of these kind of treatments that are out there for different things, and many of them are hokey, and some actually are great. So I'd have to see what exactly somebody's talking about.
What type of coating is best for aluminum exposed to elements?
So the best coating for aluminum is Kynar, by far.
Heiner, that's a brand?
Kynar is a brand, and a non-branded name for Kynar is PVDF, polyvinyl diol fluoride. PVDF. PVDF has been around for 64 years, and it is by far the best thing money can buy. There's nothing like it. Resists ultraviolets, resists acids, resists all kinds of stuff, and lasts a long, long time.
Okay. And is this a coating material?
It's a coating material that's used on aluminum. It's used on aluminum roofs. It's used on aluminum windows. It's used on aluminum panels. So anything architectural aluminum, it's used for.
Is it baked on or is it rolled on? How is it applied?
So it's typically baked on, and it's applied in a factory, and it's applied electrostatically. So it's basically very microscopic level. It sticks. It's very thin. And then it does go through a baking type of a scenario. It goes into an oven for a short time. So it is a baked on type of coating. It's not dry coating. It's not powder. It's wet.
It's wet. Okay. So if somebody has an issue with their existing structure, they in essence need to remove whatever they have that's failed and then bring in and apply a coated.
Right. So for aluminum, there are items like PVDF that are wet that are made to go in the field. And when you're doing that, you have to go all the way down to the metal. You have to go all the way down to the aluminum, raw aluminum. You have to put a finish down, or you have to put a primer down, which is a chemical conversion process. You have to chemically convert the surface of the aluminum. Then you have to apply a wet coat of paint. And that wet coat of paint can go in the field. The field applied coatings, like the PVDFs, will have a 10-year warranty max, as opposed to the factory applied that have a 20-year or 25-year warranty.
Okay, so Karim, let me just say, for an HOA board, this is a little complicated, right? This is maybe a little bit too much work, and you know, they have their day jobs, right? So would you suggest, how do you suggest that someone learn about this? I mean, and actually have the project managed?
You know, it's no different than fixing a complicated car. You don't open the hood and start fixing your engine that's broken, right? Hire an expert, hire a mechanic that knows what they're doing. Fixing aluminum coating failures is not for the faint. You don't hire a painter and say, go roll some shit on and it's going to work.
Yeah.
You hire an expert to say, okay, I got a situation here, analyze it, because it's an expensive long-term thing that you're trying to fix.
Okay.
And so you need an expert that really understands the coating. And it is such a complex thing. I've seen in the last 10 years, we have uncovered, I would say, $5 or $6 billion of coating failures.
Sure.
And so it's all over the place, all over the condominium. Most of them are condominiums. And so they need to be fixed, and people need to be aware that this is a professional's job.
Okay, well, here's the issue I see is that some of these are really replacement. These are big projects because you're not talking about just going out and slapping some coating on something. You're talking about removing the aluminum light poles and putting in new ones, right? I mean, in essence.
Essentially, yeah.
Yeah. Okay. That's what I wanted to know. And I think a lot of folks have these aging buildings and they're trying to figure out, you know, do they actually need to go in and remove those things, or is there some other less expensive way to go about it?
Light poles might be something you can paint with regular kind of paint also. Right? You could put something like a regular paint on a light pole. You're not expecting to have a nice shiny architectural finish. Is not that important to people. So those can have a less expensive type of paint used.
So given your experience, is the life expectancy of a building about 50 years?
That the IRS has a definition, I think it's 39 and a half years, and I laugh at that.
Okay.
Because I live in a house that's 119 years old, and I'm proud of it. I have original windows that are 119 years old, and so I've got my money back from the IRS when it comes to that. And of course, you go to Europe and you see buildings that are thousands of years old, more than 1,000 years old, and they're in operation. So the answer to your question is really depends on how they're built. There are lots of structures in the United States that are over 200 years old.
Right. When is a building considered a new building again? When is it renovated enough that it's a new building?
I don't know the legal answer to that question of what IRS would treat, but I think what the way IRS treats it is they look at the capital improvement that you did on the building and then they start that cycle, right, of how many years it takes to write that off. So I don't think it's ever considered new, legally speaking. But there are people that tear everything down to sticks and they rebuild everything, right? And they're renovation. They call it renovation. And in that case, it's just a renovation. So there are tax implications of that, which are a little different than reality.
Well, we won't get into the tax implications. We'll stay with whether the building's going to stay up or not and whether it's going to be good. Because I think one of the questions here is and if I can read around some of the questions, is that you have a situation where you can repair and you can maintain. And when does it reach a point of its useful life? It's no longer going to be a good idea to continue. You may have a beautiful Victorian home that's 150 years old. But I'm sure that whoever owned that building over the years had to put an awful lot of extra work into it and do replacements. Should HOAs be thinking that way with their buildings?
So there are some older low-rise buildings that have reached that point and beyond. Okay, and frankly, it makes more than sense to just tear them down and build new and maybe build at a higher density. Classic example of what you're asking, a Victorian building, a Victorian house. The structure might be okay, and the siding might still be okay, and the windows might be operational, but the function of the inside may not be. You might have a kitchen that is, 7 foot by 10 foot, and nobody wants to be in that kitchen. It's not integrated with the rest of your living room, and the layout is terrible. And you'd have to spend a lot of money to kind of, renovate the inside and to create the space the way modern spaces are.
Right.
And so that's probably the number one reason why people tear buildings down is because the cost, not just the cost of maintaining the exterior, it's the interior function is just obsolete.
Okay. So maintaining your codes and making sure that you have the right amenities in place. We're starting to see this a lot with insurance companies requiring certain changes to the buildings that their clients have. For example, removing of aluminum wire, the removal of Zinscos, panels, things like that are happening right now to try to reduce the liability of these. So the demands from outside non-agency organizations are starting to have an impact on these buildings. And so there's going to be a cost benefit of doing that, correct?
Correct. Yeah, exactly. You get to a point where, enough is enough, right? Where you may want to take drastic actions.
Okay, so we're getting right close to the end here. I'm going to do some rapid fire questions, some maybe single answer quick questions here. Is it a good idea to mount solar panels to a flat garage roof?
Yes.
Okay.
As long as there's space there, it's okay. But the caveat is, if it needs new waterproofing or roof underneath it, do that first. If it needs slope for drainage, do the slope first.
Would a specialist inspect a podium leakage and garage wall water intrusion? Is that if there's a
leaking podium costs about $200 a square foot to repair. It's more cost than it costs to build a brand new house in Texas. Is to just fix your podium, okay? Very expensive. Do not attempt to do this on your own. Hire an expert.
Okay. 20 years ago, we put Duraflash flat roofs in. Is that I assume this is someone who likes Duraplast or Last. So.
I think it's Duralast.
Yeah.
Duralast is a PVC roof, and PVC has been a pretty good material and a sustainable material. And I expect a 40 mil Duralast to last 20 to 25 years easy.
How would you inspect a lateral type work? Is that something an engineer should do, or is it some other profession?
What do you mean by lateral work?
Lateral sewage lines.
So we do a lot of sewage repair work. A huge part of our repair business is that. So we have to do video scoping. We have to examine it. If the work is underground, often the underground, we may be able to reline some of the underground so you don't have to disturb the areas up above. But
Okay.
the pipes up above, we would typically replace.
Okay. So here's another quick one. Be my last question. What's the proper seal if any of the wood cedar shingles? What should you use for a seal for wood cedar shingles?
I can't name you products, but essentially the first thing you need is to really clean it, and just proper cleaning and doing some light oil is all you really need to do. Because what causes them to fail is that the cracks, the joints in the cedar shingles, they fill up with leaves and dirt that causes them to rot. So if it's clean and it's draining correctly and it's drying correctly, they can last a longer time.
Perfect. That's wonderful. I appreciate your answers to these, Kareem. It's nice to have someone with your type of expertise and knowledge, and especially experience in the field as well as in other more litigious locations to be able to help and advise our homeowners. So what we're going to do is pass right through the Q&A session. That's it. And we're going to have some concluding remarks here. First of all, I'd like to say thank you very much, Kareem, again, for coming today and being part of our program. I hope the people here appreciate the time he's put into his slides. The deck was, I don't know, some 80 slides or so. And I want to thank all the members of ECHO who are here today and who support ECHO in our webinars. We really can't do this without the support of ECHO members. And so we encourage all of you that aren't ECHO members, and there are many of you on this webinar, that you consider becoming a member of ECHO. We would really appreciate it. We try to keep the costs as low as possible, and frankly, it's your membership dollars that support and maintain ECHO. And we don't really have a significant level of support anywhere else. It's the membership that pays for our educational programming. So if you're interested in joining, simply go to www.echo-ca.org and click on the membership tab. You can sign up. It's fairly easy. And if your community is a member, everyone in that community can avail themselves of our resources. For ECHO members, I want to thank you again for supporting us. And please invite your friends, boards, and especially management firms and vendors to join ECHO, especially those management firms. Get them to join. There's a significant amount of consolidation going on, and we've seen the loss of a lot of management companies over the last few months. A simple invitation is all it really takes to get some of these people to think about ECHO as an investment for them and for their clients. For ECHO members, again, thank you for supporting us. If you would like to become a member involved with ECHO, if you'd like to volunteer and maybe participate, we ask you to give me a call or send an email to me at dzapponi@echo-ca.org. We often need people to help us at our in-person events, to help at the Reg table or doing something there. We also need people to help in writing articles and reviewing articles, things like that. Nothing that's too difficult to do, and we certainly would love it if you could participate. And now for our other announcements. This year, ECHO has launched a new educational program focused on HOA board member preparedness. The core curriculum of 10 courses is designed for high-quality training and is available for HOA board members, interested homeowners, and professionals. Your participation in this program will earn you the Certificate of HOA Board Member Preparedness, or BMP rather. The course will initially be offered live via webinars, with 8 of the 10 courses recorded. And if you missed the live program, the course will be offered on demand as a recording. If you or someone you know wants to enroll in a certification program, please send an email to Connor. He'll set you up with the register the registration and get you engaged in that program. You have 3 years to complete the full course. So if that's an issue, it's fine. It's designed as an annual program, and we hope you can do that. And like we said, 8 of the 10 courses are on demand. If time is an issue, you can do it at your leisure. Connor's email is on the screen, I believe, Connor. So we got it there. Our 2024 resource panels for fall are coming to a close very soon. So these are our smaller meetings where we meet and engage with our professional service providers, have a couple of conversations, and then we do a little crosstalk between the homeowners. So we hope you can attend those. We have one in Orange County and San Diego on October 9th. We'll have one during the day in Orange County, and then we do a little wine tasting and event in the evening in San Diego. At the Orange County panel, we'll be discussing planning for long-term maintenance, and at San Diego, we will be discussing financials and how to read financial statements. We look forward to seeing you there. It'll be a lot of fun. ECHO is also planning 2 larger events this year. One is going to be this Saturday in Laguna Hills in Southern California. We have a number of noted speakers coming to that. Mark Guthius, Gene Grove, and Steve Tinley, all attorneys, will be discussing various aspects of new legislation, ongoing legislation, the electronic balloting issue, lots of different things there. Sean Anderson from Association Reserves will be discussing the reserve studies. And so you'll get your questions answered about reserve studies and long-term planning and what's included as components in the reserve program. There has been some changes in what they will be including. I think they're pretty minimal, but they will be putting or adding new components that you can't see. Once again, I want to thank I want to thank all of our sponsors for making this community conversation possible. And thank you again to Kareem and Adrian. Thank you as well, his support person here. And you did a wonderful job, and I appreciate that. And of course, thanks to all of you for attending today and making this a successful event. ECHO appreciates your investment in education to foster a better quality of life in HOA communities.